I want to talk about the keyboard device controller. First of all, I want to introduce what device controller is and how does it works. A device controller is electronic hardware that is responsible to handle signals used by particular external I/O device and converting them into signals that are compatible with the computer system bus. It can be divided into three kinds: input controller such as mouse, keyboard; output controller such as screen, speaker; and communication controller such as ATM. How do we transform data? We have three techniques. The first is programmed input and output. With this technique, CPU gets data from device controller, and it is CPU's job to transform data. The second is direct memory access. With this technique, device controller bring data to CPU, and it is the device controller's job to transform data. The last is shared memory. That means there is an area of memory which is visible to both CPU and input and output device. How do we know when an I/O operation is complete? We can handle this by busy waiting and interrupts. Busy waiting means processor must check frequently to see if an I/O transfer is complete. And interrupt is that the I/O device notifies CPU when transfer is complete, and then CPU will interrupt what it is doing. The keyboard is connected to the DLX machine from the keyboard device controller, which has two registers: the keyboard control register and the keyboard data register. The lower 8-bit of keyboard data register is called key code. It contains the character code of the key most recently pressed on the keyboard. The keyboard control ready bit indicates that a valid character code is pressed. For example, if the last key pressed was A, then the keyboard data could contain the value 041. Then, controller hardware will automatically set the keyboard control ready to 1. After the controller hardware returns the character code, and it will clear the keyboard ready to 0.